and welcome to the Deep Edge podcast. Here's where we dive deep into some of the trends, some of the challenges, and some of the innovations that are shaping our world of technology. I'm your host, Ray Mota. I'm CEO and Principal Analyst for ACG Research, and we're going to explore deeper into some of the evolution landscape that's pushing boundaries, whether it's in the enterprise service provider space or public sector. And one of the interesting things that we see in the market is if we look right now, the industry is at a crossroads. We're witnessing an unprecedented surge of the adoption of AI power network solutions that are not only transforming networks and how they're managed, but also addressing the traditional architectures and how they're being built for the future. Companies are facing challenges on how to be more efficient because consumers in some of their B2B are moving at a fast rate. But how do we address this when looking at things and leveraging machine learning, time series analysis? Specifically in this area of this podcast, we're going to go deep into some of the issues related to routing, that point of view, especially when we look at things like black holes and major outages, which was always a nightmare for me when I was a CTO on Wall Street. So these adoptions of these applications, specifically AI, become an important factor. But while doing that, how do you become very energy efficient, right? So there's some game-changing technologies and trends because there's many service providers and enterprises that are looking to not only address overall OpEx, but also be more energy efficient. And some of them are requiring to understand the requirements on how these products are being built on top of just the CTO. So these cutting edge technology is what's going to help us be able to deliver services more effectively, more efficiently, because AI is technology, but AI that provides economic benefit, it becomes very important. So in this podcast today, I'm excited because we have joining me today is AE Natarajan, who's Executive Vice President and CDO, Chief Development Officer for Juniper Networks. And here we're going to go deep into where I'm questioning him into an announcement that his team just provided as related to AI native. So let's get this started. AE, thanks for joining the podcast. I really appreciate this. I know how busy you are, especially with Barcelona right around the corner. So thanks for joining, my friend.
Hey, thank you, Ray. It's a pleasure to meet you. And especially on a day when I have to be indoors. California, it's raining and cloudy. Can you believe that?
Oh boy, no, it's sunny here in Arizona. I was just in DC and it was a snowstorm. So I'm glad to be able to get out of there. But AE, I don't know if you know, but I go way back with Juniper and Cisco. I used to install the AGS Pluses. You remember those?
Oh,
And
yes.
Juniper's first router, the M40's multi-service edge router with Junos. And I liked it because it moved away from this old monolithic operating system, so I was able to work on OSPF without impacting ISIS. So we go way back. Now, maybe before we get started, AE, for our audience, if you can talk over a little bit about what your role is at Juniper and your overall initiatives.
Oh, absolutely. Ray,
Okay.
I know we both have had discussions. My current role and responsibility at Juniper is I'm Executive Vice President, CDO, responsible for all of Juniper's wide area network products. So essentially, all of the products that you're familiar with, whether it is the MX, the PTX, the ACX, the chip technologies, whether it is the Trio or the Express family of chips, and all of the software associated with it, getting it out to the market and building on top of it. And that's my role and responsibility. And you and I have had several conversations about
Yes.
how things have actually transformed in this space and continuing to transform, right? So really, really excited to be here and be part of this podcast. Yeah.
Yeah, no, I'm excited because one thing is you have a good balance of being able to have an executive discussion and be able to get into the technical parts of it, which I enjoy. So maybe we can start off with I had a briefing with your team with some of the announcements on the AI native type
Mm.
strategy and maybe talk about differentiation and positioning, right? When with companies building their own AI tools and dealing with more traffic, right? How does Juniper's new AI-driven solution help them stay ahead, right? And then also, what are some of the key benefits that this offers compared to traditional networking system?
It is very interesting, Ray, because first let's take a step back, right? And if you go back almost 10 plus years ago, you're familiar with Kiriti Kampala from our
Of
team.
course.
And Kiriti started talking about self-driving networks because we saw long time ago that the networks were getting complex. Managing, maintaining, operating the networks is becoming even more cumbersome and complex. The only way to go about that is the ability to actually have automation. And automation doesn't come easy. It actually comes with understanding the network, understanding the nuances of the network, getting the right levels of data and telemetry from the network, building advanced heuristics, building models to actually make things happen. And I'm speaking all of the words that we use in AI today to actually drive what we need to do to make networks easy to build, operate, scale up, and run our networks in this complex environment. No longer are networks just, I have my favorite phrase. We started off with DARPA building the entire internet on if you got a datagram and you got the packet, be happy, right? It's no longer the case. Our 911 services, our critical services run on it, and our ability to actually make this work is really important. The good news is, with some of the inventions that we have now, with the ability to take AI models and build it into these routers, we can now make self-driving networks, scalable networks, networks that can actually understand the operational nuances of what is happening and really build out on that and drive for anybody who's building networks or who's operating the networks, give them the visibility, give them proactive triggers and stuff, ability to very, very quickly detect faults, correct faults, change, and make things so resilient and reliable. So our critical services really run very well on these networks. So these are some of the challenges, and we saw it way ahead, and we have actually built this into our products, our routers, our controllers, our automation tools and technologies to really, really build and grow on top of it to help everyone who's building networks. It doesn't matter whether it's a service provider, whether it's a cloud provider, whether it's large enterprises, small enterprises, everybody needs this.
Yeah, no, it's a good point. It's more than just service providers. It applies to all those because I do remember when Kariti came up with that concept. So it's good to see it come closer to fruition now. As part of the announcement, there was some hardware innovation. I think it was the ACX 7020 routers, which is key part of this offering. Could you explain any hardware innovation, especially there was some components there which was important to me, which is related to the energy savings feature where you're able to do port shutdown and smart power management, but also kind of out of the box, it's connected to some automation capabilities like Paragon. Could you talk a little bit further about that?
Oh, yeah, absolutely, Ray. Actually, you can see me really getting excited about these topics because, it's almost about a year ago when we talked about how operating cost and sustainability and performance and automation are so critical for every part of the network. Some of the major innovations that we're doing because we build our own silicon, we start with the silicon, whether it is the Trio family of chips or the Express family of chips. The Trio family of chips, if you really look at it, we are in almost the sixth generation of the chip, right? And it carries such a plethora of sensors and telemetry straight from the chip. You and I talked about it. It can actually give you data plane telemetry streamed from the chip at the data plane level, which gives you the highest scale that you can actually get. So the first order for us to be able to actually observe, manage, monitor these networks is for us to first get the right levels of data and the data from the chips and from not just our chips, from our silicon, from our software, from every piece of it. Once you have this data, then you have the right models that have learned from this data and adapt this to make inferences and actionable things that can actually help with automation and self-driving that we've been talking about. So we start with the chip, and then we have transformed it to the next level and the next level. We're making some innovations. You touched upon it, which is green traffic engineering. This is when we hired our Juniper fellow back again, one of our founders, you know him, and he said, I want to build a model to solve traffic engineering, only to guess that that is the same model that will actually help with green traffic engineering and reduce sustainability. We've got concrete examples where we have reduced power in certain networks by 73%, not one or two. This is amazing story where we build these innovations, and you touched upon the 7020, the new ACX. It's completely tied to be cloud-driven, cloud automated, drive all of the things. But the ACX is not just built on our silicon, but it's actually built on AI native inside our devices. Absolutely exciting to have that.
Yeah, no, this is good. I mean, because power, and especially a lot of different parts of the world is becoming a high priority now. Another part of this, when we talked about automation, is related to this whole, and we've talked about this in the past, about this, whether we call it intention-based or intent-based networking. And correct me if I'm wrong, but your solution is able to convert service quality goals into specific network settings and checks, right? How does this ensure that customers I kind of get the expected quality, and especially I think the part in a multi-vendor type environment?
Very interesting. And the reason why we're talking about how our solutions actually drive this from a multi-vendor environment is because no customer is going to have a complete greenfield or just a Juniper only network. We need to actually work in a world which is heterogeneous, and we need to make the life of the operator very simple so that they can build their networks and operate their networks. And you cannot throw away legacy simply overnight, right? So you have to embrace it and make it really better to what we're doing. So intent. So what we've done is networks have become more complex to build out, configure, and automate and operate these networks. It is also getting complex, and we don't have skill sets, and everybody is facing that. There is skill set dirt, there is all sorts of things. So what we intentionally did is you want the network automation to understand what you want to do with the network. I want to provision this service and say, I want to provision this VPN service between New York and London. Automatically, because the automation software knows the network, knows what links are there, knows what traffic is running through it, knows the priority of what you want to do. It is automatically able to look at it holistically, provision it, make it happen, and automatically turn on configuration in each and one of the intermediate systems to enable the service to turn on in a flash. So it's almost like a push button. Not only does it do that, it actually turns around and automatically makes the controller or the visibility agent to look at all of the telemetry associated with what is going on in that and that service, so that you know how well the service is working. And if there are proactive things like black holes or link flaps or link drops or gray failures, we are able to use our AI models to start predicting and detecting them so we can actually resolve some of these problems. And we do this agnostic to whether it's a Juniper router or something else, because we have our own built-in probes that can actually step through each one of the nodes and do it. In some cases with Juniper routers, we have an undue advantage because we know more, right? But in other cases, we try to push a lot more standardization to actually build on top of it, whether it is open config or standard models that you can actually drive and push to make things a lot more easier for us to observe and manage that.
Yeah, no, I mean, I think it's more, like you said, a network that works for you, not you work for the network, right?
Absolutely.
So I think it's a good way to put it from that side. Now, the other part, and you touched on a little bit, but part of the briefing with your team was related to scalability and provisioning, right? Is one of the key things they mentioned was about, connecting thousands of endpoints in minutes instead of weeks, right? What design choices make this possible, right? It's like I'm concerned about how do you handle potential latency and reliability at such scale.
But very true. It's actually one of the most complex problems in a network to actually handle scale, right? If you really look at our networks and why we're continuing to innovate in our networks is because as human beings and as machines that we connect through network, we become more and more hungry for bandwidth, more and more hungry. And AI has actually taught us to actually increase the amount of bandwidth and performance, right? I mean,
Right.
800 gig is not sufficient. We're now looking at 1.60. We're
Jeez.
looking at all sorts of things, right? And unprecedented scale, right? So fundamentally, the architecture and the process with which we are able to do is there are two ways to scale. You either scale up or you scale out. The ability for us to actually build products and architectures that can cater to both scale up and scale out. We will have the densest, smallest 800 gig, which we announced in MWC last year. If you remember, 36 ports of 800 gig in a fixed form factor, 2RU box, right?
Right.
Most densest box that you can see, 800 gig, and people just love it. But if you want to scale up and scale out of that, and what you do, we have architectures that actually help you to build that kind of a scale. And because we do this intentionally with how we build our products and our software, we actually come out really big in giving the customer the flexibility. You may need a site which needs a small. You may need a site that needs a medium. Somebody needs a large or an extra large or an extra extra large. And today it is a medium and tomorrow it's going to be an extra large. How do you actually manage all of these things, right? We do a tremendous job of scaling up, really, both with our scale out capabilities and building on top of it, right?
Yeah, now I want to get back to a question you touched on about black holes, right? Just because I think as a former CTO, that was always a concern and important for me, right? But in this case, like you talked about, what we're using or what you're deciding to use and presenting is more related to what I call AI-driven network routing observability, right? So when we look at that, you're leveraging, whether it's machine learning or sometime serious analysis to address black holes, which I think is a very important. Is there anything you could elaborate a little bit further? Because to me, that was always the part I used to lose sleep over, not having that routing observability, and now leveraging AI could be really powerful for some of our audience there.
Yeah. So Ray, you know this hands-on because you used to run networks, right? When you run into a black hole issue, the first time you hear about it is a customer on the other end of the phone calling you and saying, "My application is not functioning. Something is happening in your
Yes.
network, and it used to work. What the hell
Yeah,
went
they
on?"
don't call you to say
And
hi, how you doing, right?
they don't even talk to you about it, right?
Right.
And then you say, okay, let me look into it. And then you start tracing every path of where the packet could have traversed. And it's a complex network. It is going to be load balanced. Packets travel all over the place. All of those things, right? And to triage something is going to take hours, days, and sometimes you may not even find it because it was transient and somebody else rectified something else, right? The ability that we have with the telemetry and the visibility and the observability, both from a control plane, from an admin plane, and also from a data plane, we have tens and tens and thousands of sensors and telemetry from each one of these devices. It is almost like having a million eyes looking at your network at the same time. And the ability for us to take those million eyes and get all of that and correlate it into a model, we're able to actually very, very quickly detect black holes and point at where the problem is. Hey, this is a gray link. This is why you're having a problem over here. Or redivert your traffic because you're getting congested over here. Or somebody bought this SRLG link, and so you're facing the wrath of this because that is what it is. But it is a combinatory of several different things. And last but not the least, sometimes it is just a matter of network convergence.
Mhm.
Upstream node has converged and the downstream node hasn't converged as yet, or your inbound has converged and your outbound hasn't converged. So you're dropping the packets simply because it is a convergence issue. How do you actually detect these? And last but not the least, sometimes these are just pure human software bugs.
Right, right.
Detecting that and bypassing that and fault isolating it, it's actually fun. We've had several cases of black hole detection that is very effective and is being used by, surprisingly, Ray, large enterprise customers,
That's great.
because they actually, their IT division looks at their applications and they say, oh, this is useful. This is amazing.
Yeah, now I liked your example because it reminds me of this analogy that we call the jelly bean experiment, right? Where you put a certain amount of jelly bean where you could have one jelly bean expert predict how many jelly beans are in a jar. But if you get 100 people or more guessing, they consistently are more accurate over time. So having more eyes helping you do your job is, I think, a good example of that. Now, I don't get excited very often, but there was a part in here, part of this announcement, which was related to, I think you call it the LLM connector, right? The
Yes.
large language model. Now, in that feature, one of the things that I wanted to ask you was related to how flexible is that LLM connector, especially when you look at various business needs and how does it help troubleshoot in a real world example there?
So let me tell you why I'm very excited about this LLM connector. So first and foremost, one of the reasons why a lot of people hesitate to use their own networking data to train open models, right? LLM models, because they want data protection. And there are some tools and mechanisms today to do that. But nothing more comforting than having your own private LLM model where you can rely on data that goes straight from your devices into it. Okay, that gives you ability to actually train those models with your real life network data, which is one. So that's one of the important pieces of the LLM connector. The second part of it is actually agnostic to the LLM model, because LLM basically gives you a GAI, so you can actually interact with that and actually have conversational AI with the whole thing. And there are several models. If you like one, pick one. Okay. But what we can do is we can take some of our learnings and superimpose on top of it. And we have actually done something within our own operating system, Junos and Evo, which is patented technology that automatically gets you into this conversational interface and redirects it either to well-published entities to get the answers. And sometimes when you go to the net and actually try to get and read these answers, you may not always get the right answer, right?
Right.
There are hallucinations. But the beauty of this LLM connector is it actually uses the real live data from your own network, from your own routers, from your own telemetry that it has. So its ability to actually analyze and give you the answers is so precise.
Right.
But what got us even more excited when we actually did this in front of customers was because I was able to leverage LLM's innovation, where I no longer need to translate. I could sit in front of a Japanese customer and type in kanji characters, and the answer came out in kanji.
Wow.
And you can do that anywhere so that people can actually comprehend and have a comfortable conversation without any translation. And where they can rest themselves on this is it is actually based out of real data coming from the network. And it is protected because it's your own LLM that you have installed and you have done it. That's the beauty of it. And it is amazing to have this innovation in our portfolio. So this is exciting, Ray.
Good. So you validated why I should be excited because I was excited. I go, why am I getting excited over this? Right. So it's good to hear that some of your customers are feeling the same way. Maybe just close with, but there's a point I want to just reiterate was you mentioned some of the power reduction and stuff like that. Because normally a lot of these calls, when I look at new technology, I always say, okay, what's the business, whether it's TCO, ROI and stuff like that. But when you can get a high double-digit reduction in power, that in some cases is enough of an ROI
Yes.
for some. Were those numbers right and stuff like that? Large power reduction?
Absolutely. So,
Mhm.
so I mean, I quoted the 73%,
Mhm.
which is one example.
Okay.
There's another example where it is about 32, 33%, depending on what.
Yeah, depending on
So
the, right. Yeah.
it is significant enough
Yeah.
that based on how your network is architected, how your traffic flows are going, we are on an average seeing anywhere from 30 to 70% very easily. And if
Nice.
you really look at power bills, that actually is significant reduction.
Right. Now,
And yeah, you're
no, that's
absolutely.
good because then I just want to make sure to clarify that part. Maybe AE, we can close with putting back your executive hat on, right? Is looking at the long-term vision right here and getting more of your input when we look at Juniper's network long-term vision related to AI ops, autonomous network, especially in this fast-moving world, how do you continue to overcome and help your customers overcome these challenges while still maintaining, I guess, network reliability and things like that?
Yeah, it is critical and important, right? Because Ray, some of it doesn't come easy, right? You invest in some of the fundamentals ahead of time. The good news is Juniper, all the way from how we build our silicon to how we build our systems to how we architect our software and how we embrace some of these things, we have done it in such a way that we are able to actually manage the growing and changing needs and demands of the networks of today and tomorrow, right? Whether it is scale, whether it is performance, whether it is the automation piece that we talked about, whether it is the power consumption and sustainability, we think about all of those things as we build our stuff. Because if you really put it in very, very tight power budget environments, our silicon is probably one of the best.
Mm.
And actually, I would dare say it is the best in terms of how we do it, right? In terms of what we do in the world. And this gives us the ability for us to actually manage the changing and growing needs of the environment much more easily. The best example is the MX that we shipped 15 years ago is still doing
I know.
segment routing today, which was invented about 7, 8 years ago. And it's today the highest scale than any other network processor that you could have in
Wow.
terms of what we
Wow.
do. So that is a true testament to how our fundamentals have really helped us build what is there for today and for tomorrow.
Right. Yeah. Investment protection, all that. Well, AE, I appreciate your time. I know how busy you are. Thanks for joining now. Hopefully I'll get to see you at Mobile World Congress and so the speed dating event right there. So
Yes,
hopefully,
absolutely. And
yeah,
I think
yeah.
we'll have some personal time together too in
Oh,
Mobile
that'll be great
Congress.
there.
Yes, that'll be
Awesome.
awesome. Looking forward to it.
Yeah. Well, thank you again. And with AE, this is Ray Mota. Thanks for joining this podcast.
Thank you. Cheers.